Good morning and welcome back to Dr. Logic Awkwardly Does Logic in her office. I've missed you guys. Hope you're all doing well and are ready to do some more propositional proofs. I've given you rules, I've given you examples, but today I'm actually going to talk to you about how to go about doing them. So what I'm actually going to give you is an algorithm that at any step you can look at it and it will tell you what you need to do next. Now, it's not going to be quite as methodical as the one for the syllogisms, where you can literally read the proof off from the mnemonic. There will be times where the algorithm says, you have to figure it out yourself. But for like 90% of the other times, this will help you if you ever get stuck doing one of your proofs. So I'm going to try to talk you through the algorithm without writing it down, because I think writing it down and talking at the same time would be an awkward step too far. But don't worry, if you want a written version of it, it's in the textbook that is linked in the description of this video. So you can go there, it's round about page 93, 94, and you can see in writing everything that I'm going to be saying in words. So the first thing that you have to ask yourself is, do you have any assumptions? Is what you are trying to prove a conclusion that follows from certain premises rather than no premises? If you do, write your premises down, annotate them with assumption, and then if you have assumptions, go through and use as many elimination rules on those assumptions as you can. So if you have a conjunction, break it down into its conjuncts. If you have a conditional and its antecedent, do conditional elimination to get the consequent. If you don't have any assumptions, or if you've used all of the elimination rules that you can, then the next thing to do is look at your conclusion. What is the main connective of what you are trying to prove? It is either a conjunction, a disjunction, a negation or an atom, a conditional, or if you're in like a subproof, you are trying to prove a contradiction, but you don't necessarily know which one. So let's consider the case where what you're trying to prove is a conjunction. You can think of this as simply being two smaller proofs where you prove each of the conjuncts individually, and then you can use conjunction introduction. So now, instead of thinking about how do I prove the conjunction, you're now thinking in terms of how do I prove the conjuncts. And this is where you kind of loop back in your algorithm, take one conjunct and ask yourself, what is its main connective? Conjunction, disjunction, etc., etc. If what you are trying to prove is a disjunction, then you can use disjunction introduction if you get one of the disjuncts. So you don't necessarily know which one, but you've got another set of, you've got another kind of mini goal, mini proof, and you can say, okay, I'm going to try to prove the left-hand disjunct. Ask yourself, what is its main connective? Is it conjunction, etc., etc., etc.? If what you are trying to prove is either an atom or a negation, then what you want to use are the negation, elimination, and introduction rules. So negation, introduction, if your main connective is a negation, and if you're just trying to prove an individual atom, you want to use negation, elimination. So what you would do is you would then assume the negation of your atom and try to derive a contradiction. As soon as you've made a new assumption, you're then in a position where you go back to the do you have assumptions line of the proof and see what more you can do. Now, if what you're trying to prove is a conditional, the conditional introduction rule says you need to assume the antecedent as the assumption of a new subproof and then try to derive the consequent. So in the same cases with the negation, elimination, and introduction rules, you start a new proof that you work in. New assumptions, cycle back to the beginning of the algorithm and ask yourself, okay, can I apply any elimination rules to my new assumption? If not, what is the main connective of what I'm trying to prove? So in a conditional, that would be the consequent. Is that a conditional, conjunction, disjunction, etc.? It's always going to be one of them. And so you can see how this process kind of keeps iterating back on itself with different formulas under consideration. Now, if what you're trying to prove is just a contradiction, but you don't necessarily know which one, this is the one where you can't just blindly follow an algorithm. This is the one where I go and say, good luck, gotta figure it out yourself. Now, of course, a lot of times it's not just completely opaque, because you will be able to see in the formulas that you have that you've got some atom and some negation, or one of the things about proofs is that the more that you do of them, the more that you start recognizing patterns. And pattern recognition is how you identify what contradiction you want to aim for when doing the negation elimination or negation introduction rules. So it's something that comes with practice. Don't worry if you're not immediately seeing all of these things, because it will come. Keep working on the examples that I gave in the previous video. Somebody let me know that the screen sharing didn't work, so I put a link to the actual file in the comments on the previous video. So if you need examples, there's plenty to do. Then, kind of two more kind of things to think about outside of this kind of iterative algorithm. First of all, if ever you are stuck, go back and look at your assumptions and see if there are any that you haven't used yet. If you haven't used them yet, now is probably the time. It's rare, it's not impossible, but it's rare that you are given premises that are redundant, that don't get used at all. Also, look at what you are trying to prove and find what other formulas in your proof have the same atoms. Because you have to have, You have to have the right atoms, otherwise you're not going to be able to prove the thing that you want to prove. So look where you have other occurrences of the atom you're trying to get, and then see, are any of the introduction or elimination rules ones that you can use maybe with a combination of the formulas. And lastly, my third trick that I'm going to pass on to you is use derived rules wherever you can. And I hear you saying, but Dr. Logic, what is a derived rule? That is going to be the topic of the next video. They are essentially a bunch of shortcuts that make your proofs and your life easier. So I look forward to seeing you then. Take care. Cheers.